Hello everyone, I am Miss Pooja and welcome to our hydrocarbon series. In this hydrocarbon series, students, I will be explaining all the major topics, that is alkanes, alkenes, alkynes and aromatic compounds. At the end of every video, I have shared key points which will definitely help you to understand the concept in a very simpler way. Along with that, you can also take the screenshot of my handwritten notes. Now let's start with the first topic, that is alkanes.
Alkanes. Now alkanes are the hydrocarbons in which carbon-carbon single bond is present. If carbon-carbon single bond is present, then we know that it is a saturated hydrocarbon, right? Alkanes are also called as paraffins. Paraffins are basically less reactive. Okay, they are what? They are alkanes are less reactive. Talking about now the chiral carbon. Now in alkane, if chiral carbon or unsymmetrical carbon is present, then it shows optical isomerism. In the previous chapter, everything related to optical isomerism I have explained. Kindly go through all the previous videos. Next is the general formula of alkane. Now, general formula of alkane is CnH2n plus 2, where N is the number of carbon atoms. It can be 1, 2, 3, 4, or anything it can be, right? Now, talking about the hybridization state of carbon in alkane. Now, if I say, let us take the simple alkane, that is methane. Now, if I look into methane, all the bonds, okay, all the carbon-hydrogen bonds are sigma bond. And then we have already studied in chemical bonding chapter that if it is sigma bond, 4 sigma bond, that means the hybridization state is sp3, 1s, 3p. So together we get 4, okay, 1 plus 3 is 4. So 4 sigma bonds, okay. Coming to the geometry, if it is sp3, we have again studied this concept in hybridization. Okay, if it is sp3, then the geometry is tetrahedral. Okay, the geometry is what? It is a tetrahedral. And then the bond angle is how much? It is 109 degree 28 minutes. Okay, coming to now carbon-carbon bond length. Now in alkane, okay, let us take the example of ethane. This is the second member of alkane. Now, in alkane, the carbon-carbon bond, this bond I'm talking about, okay, the carbon and carbon bond, it is what? It is having the bond length 1.54 Armstrong. Whereas carbon and hydrogen bond, it is having the bond length 1.12 Armstrong. Clear? Now, talking about the bond energy. Now, as I can see, the bond length of carbon-carbon is much more than the carbon-hydrogen, right? So, if the bond length is small, definitely the bond energy is more. So, carbon-hydrogen bond energy is more, whereas carbon-carbon bond length, it is what? It is less. So, the bond energy, carbon-carbon bond length is more. So, the bond energy is less. Basically, bond energy is nothing but the energy which is required to break the bond. If the bond length is more, definitely the strength is what? The strength among the atoms, it is what? It is weaker. So, less amount of energy is required. Okay. Next is, alkane shows only chain position isomerism. Okay, it shows only chain and position isomerism. Talking about the molecule of alkane. Now, the alkanes, they are arranged in a zigzag manner. Okay, all the molecules of alkanes, they are angular. Why? Because the carbon, it is what? It is arranged in a zigzag manner, not in a straight chain. As you can see, this is one carbon, then carbon, then carbon. So, it is basically zigzag. Okay, there is no branching present. This is unbranched. On the other hand, there is what? There is branching present. Okay, branching means in a chain, okay, in a chain, there is additional group attached. So, we call it as branching. Now, let us quickly have a few more points. We will look into a few more points about alkane. CH4, okay, CH4, which is called as methane, it is also known as marsh gas, okay, marsh gas, fire damp. Calor gas, it is basically the mixture of N-butane and isobutane. LPG, okay, which is also called as liquefied petroleum gas, which is nothing but liquid propane isobutane. Then the next one is natural gas. The natural gas is 80% methane, 10% ethane, 10% propane, and a small amount of hydrogen, nitrogen, and carbon dioxide gas. Clear? Talking about water gas. So, water gas is CO plus H2 in 1:1 proportion. Synthesis gas is CO plus 3H2, that is in 1:3 proportion. Clear? Classification of alkanes. Alkanes are classified into two types, open chain and cyclic. Okay, if it is open chain, then again there are different types we are going to study. And then the cyclic alkanes are called as cycloalkanes. Let us quickly have a look on the straight chain. Now, straight chain, they can be simple straight chain like methane, propane, butane, or they can also be branched. Okay, that means on a straight chain, there is what? There is additional group attached. There is a branching. Clear? Talking about cyclohexane, cycloalkanes are basically carbocyclic compounds, okay, which are present in a cyclic form or ring-like structure. Then everything related to nomenclature, already I have explained you, right, in the previous. Now quickly we are going to start solving few questions on nomenclature.